As we look at this overarching idea of ecosystem diversity, we inherently realize that having a variety of ecosystems is important to biodiversity. Now we're going to look more at the patterns for some of how these ecosystems formed. We'll do a quick review of the three types of plate tectonic boundaries, or interactions that can happen at tectonic plate boundaries. And the first of those is a divergent plate boundary. Really, let's keep to the core of the ideas, and then you can try to apply that to understanding or describing some of the larger environmental issues. At a divergent plate boundary, plates are rifting or tearing apart and being stretched really thin, creating a rift valley. So if you picture some Play-Doh or pie crusts or maybe pizza dough, and then you stretch it and stretch it and stretch it, and it gets thinner and thinner and thinner as you do that, that is what's creating a rift valley. So if you look at the left, these are some actual images, not just a cartoon image like at the top. And what we want to understand about the processes at these divergent plate boundaries is that when the lithosphere is stretched really thin, upwelling of magma occurs because it's really thin and it's kind of weak. And so the magma splits the Earth's crust and pushes those plates apart. And that's what we call seafloor spreading when it happens on oceanic crust. Also, we create a mid-ocean ridge. So where that seafloor spreads, where the magma starts getting up in that weakening of the crust, it can actually break through and deposit magma, which will cool and solidify, creating mid-ocean ridges or underwater mountain chains. And finally, a feature that we can predict would be located at a divergent plate boundary are both volcanoes and earthquakes. They occur as that molten material is able to rise to the surface. So just understanding how our planet is divided into different lithospheric plates, oceanic and continental crust, it really helps us from a human standpoint to predict where some natural disasters can occur and how we can better prepare for those. So just to put it in perspective, the image on the top with the green, that is a hot spot over Iceland where the North American and Eurasian plate are rifting apart. So this rift is one of the few places on the planet that we can see this on the surface of land, because most of the time it happens on the ocean floor where those mid-ocean ridges form. And then the second image that my face is kind of in front of, that is called the African Rift Valley. And so as those plates pull apart, we have a lot of really cool ecosystems that occur in that area. Like the Serengeti. So we have amazing biodiversity where this plate tectonic activity arises. Let me switch to the next slide. Oh, okay, so then we also have something called a strike-slip fault. This is a transform plate boundary where we have two plates sliding past each other. This is what we commonly think of as where the San Andreas Fault is in California, where two plates are sliding past each other. It causes a lot of earthquakes, but no volcanic activity. The third type of tectonic plate boundary is a convergent plate boundary. Let me try and see if I can move my body over a little bit. Okay, so if you look at these images of where two plates converge, if you have an ocean plate and a continental plate, the oceanic plate is going to sink under the continental plate because of the density of the rock that makes up the oceanic plate. It's going to be more dense, so it's going to sink down under. And as it sinks, it begins to melt. And all of the impurities, they're going to come out first, and they're going to start rising up as magma. And then the rock itself can melt, and then some of that will rise up as magma. And this creates a lot of volcanoes right along a convergent plate boundary. Some examples of this are the Cascades and the Andes Mountains. Another very familiar idea of a convergent plate boundary could be some of the island arcs that we find around the edges of the Pacific plate. Two continental plates can also converge on each other, and that usually creates collision mountains, which are much, much higher than what we traditionally see. So the Himalayas are built this way, and the Appalachians once millions and millions of years ago were built this way. All of this tectonic plate movement happens over millions and millions of years. So it's kind of a hard concept for some people to grasp. So we have 15 major tectonic plates. If we look at them as smaller tectonic plates, there's probably about 23. And the way that we measure those is based on where we find earthquakes and volcanoes and new seafloor and things like that. So you can see in this image that the subduction zones are where you see the triangles. So we have a very large one where the Nazca plate meets the South American plate. And again, over here where the Philippine plate and the Pacific plate are meeting, that's going to cause those island arcs right there. Now, the best example of a divergent plate boundary is going to be right here at the Mid-Atlantic Ridge. So the ocean is getting bigger and bigger here. And right up in here, this is where Iceland is. It would be like the new material that's forming. And the East African Rift Valley, right in here, new material there. So this has changed over millions and millions of years and is a concept that most of you should be kind of familiar with.